Okay, new day, new topic. Today we're talking about energy and work. Our focus actually today is on energy, specifically potential and kinetic energy. So let's get started. Energy. What is energy? Energy is your ability to do work. Okay, so what does that mean? In order to understand what that means, you have to understand what work is. Work is simply energy being transformed or transferred. Transform means we're changing the type of energy, maybe changing it from solar energy to chemical energy, from electrical energy into heat energy. Transferred is giving energy from one thing to another. So again, your ability to do work means your ability to transform or transfer energy. So, as I said, we're going to be focusing on potential energy and kinetic energy. There are two different types of potential energy we'll be getting to. That is chemical potential energy. We'll also get into mechanical potential energy, which is not on here, but would fall into the etc. category down there. We'll also get into what is called gravitational potential energy. We talked about gravity earlier in this class. And finally, the kinetic energy, or energy of motion. So, the first thing you need to know are what units we are dealing with. We've talked several times about how units and understanding units are important. In energy, we use something called the joule, a capital J. Okay, so what is a joule? Or one thing you need to remember is energy can only be observed when work is being done on an object. Only when we see that energy being transformed or transferred do we actually know energy is present. Now, just like we've talked before about the conservation of momentum, something that goes hand in hand with that is something called the conservation of energy. Energy is neither created nor destroyed. Okay, so that means the total amount of energy before and after in a system is always going to be the same, just like it was for momentum. Again, that is because energy is only transformed or transferred. So let's start with potential energy. Potential energy is simply the energy that is stored in an object resulting from its relative position within a system. What do we mean by its relative position in a system? Think about a spring, and if you twist that spring up, what you are doing by twisting that spring or compressing that spring is you are storing energy in it. Okay? You are storing energy in it. By winding the spring, you are putting it in a different position that has more energy. If you lift something up off the ground, as you lift it up the ground, you are transferring energy into that object, and that way the object then will have energy stored in it so that when you release it, it will drop. This would be your gravitational potential energy. Okay, so just think of potential energy as stored energy. It is the energy that an object has. It can potentially do work. Now, there is what we call elastic potential energy. This is anytime you are using a stretched elastic material. I already mentioned something like a spring. It is somewhat elastic. Also, rubber bands would be an example of this. Bungee cords, clock springs, as I mentioned earlier, we wind the springs up. All these are examples of things that have an elasticity to them. And as you stretch them or as you wind them, this builds up potential energy. As we see here, as Wile E. Coyote stretches the band here with the bow. Once he releases that, the band will snap back to its original shape, transferring energy to him and propelling him forward. So here we have an example of potential energy. Gravitational potential energy. As I said, this has to do with gravity. It is energy that can work based on the position of an object. We've talked about how the center of gravity here on Earth is the center of the Earth. So as you lift something up away from the ground, you are doing work on it. And by doing work on it, you are putting energy into it. And we call that gravitational potential energy. That is why when you release it, there is energy there to cause the object to move. Gravitational potential energy depends on two things, and we talked about this when we talked about gravity, and that again is mass and distance. Okay? Again, mass and distance. Obviously, the higher you lift something, the more gravitational potential energy it's going to have. The larger it is, the more potential energy it is going to have. So to understand gravitational potential energy, we're going to look at this kid who's going to sled down this hill. What is his gravitational potential energy? We simply look at the height. Okay, this is the distance, and then we look at their mass. From those two things, we can figure out the potential energy of the kid. Now, how do we determine potential energy? I said it has to do with mass and distance. Gravitational potential energy is the mass of the object times the acceleration due to gravity times the height above the ground. Okay, so again, mass in kilograms, the acceleration due to gravity, that's meters per second squared, and height. Okay, that usually is in meters. So, PE, potential energy, is m small g h. Or, we talked about this earlier, m times g, mass times acceleration due to gravity, is your weight. So if you take your weight and then measure the height, you can calculate potential energy. And we all know you can use a scale to find our weight. So let's do an example. We have a 65 kilogram rock climber. He ascends or climbs a cliff. What is his gravitational potential energy at a point 35 meters above the base of the cliff? So again, we just take our mgh. He has a mass of 65 kilograms. The acceleration due to gravity, this was found by Galileo, and it is always 9.8 meters per second squared. So 9.8 meters per second squared is what we're always going to use for G. It said he climbed to a height of 35 meters. So we simply multiply those three numbers together. A kilogram meters per second, a kilogram meter squared per second squared gives us a joule. So we have 2.2 times 10 to the fourth joules, or we have 22,000 joules of potential energy. 22,000 joules of potential energy. Now, the other type of energy I said we were going to talk about is kinetic energy. This is energy of motion. This is the energy being used by a moving object. This is the energy used to cause that object to move. Again, this depends on a mass, just like potential energy did. But instead of looking at the height and looking at the acceleration due to gravity, what we're going to do is look at the speed and see how that affects it. So, which do you think is going to affect the amount of kinetic energy more? Do you think the speed will, or do you think the mass will? Okay, for example, when a car crashes, is it the size of the car that matter, or was it the speed the car traveling that is going to influence the most? I'm sure most of you guessed that the speed. Most of you would know that the faster a car was going when it crashes, probably the more damage is going to be done. So speed is a major influence on kinetic energy. So what is kinetic energy? Kinetic energy can be calculated by taking 1/2 the mass times the speed squared. 1/2 mv squared. Again, when we talk about speed, we're doing velocity. Okay, 1/2 mv squared. So if we do a problem, we have a kinetic energy of a 44 kilogram cheetah running at 31 meters per second. Again, we just take our equation, 1/2 mv squared. We plug in the 44 for the kilograms, the 31 for the meters per second squared. Okay. I'm sorry, that little square sign should have been on the inside, not the outside. And we end up with 2.1 times 10 to the 4th joules. Again, if we convert that to regular numbers, that's 21,000 joules of energy. Okay, that's how much energy that cheetah has traveling at that speed. Okay, so again, we have potential energy, M times G times H. You just have to remember that G is always equal to 9.8 meters per second squared. And we have kinetic energy, which is 1/2 mv squared. So let's talk about energy transformation. Potential energy becoming kinetic energy. One thing that you will notice, or should have noticed in the past, is that potential energy can become kinetic energy, and kinetic energy can become potential energy. Okay, for example, when you climb to the top of the hill to go sledding, as you climb, you have kinetic energy, okay, because you are moving. And once you get to the top of the hill, you now have potential energy, okay. So an example of potential energy becoming kinetic energy would be the person sledding down the hill, or the example I gave you here, a car going down a hill. The opposite, the kinetic energy becoming potential energy, would be, as I said, walking up the hill to go sledding, or a car driving up the hill. Okay, these are just examples of how we can go back and forth between kinetic to potential and potential to kinetic. So if we look at this picture here, we have a person riding a bike. As they go in or up the hill, they are putting energy in. So they are building up potential energy. Okay. When they get to the very top of the hill, they have the maximum number of, or the maximum amount of potential energy that they're going to have. And then when they go down, that potential energy is converted back to kinetic energy. So energy is coming out. Okay, so in other words, energy in, you have to pedal to get up the hill. Okay, energy out, you can coast down the hill because you're just using the potential energy that you put into the bike as you were going up. Okay, so when you see something like this, the maximum potential is always at the top of the hill, And the maximum kinetic energy is always going to be at the bottom of the hill. When that person comes back down and reaches the bottom, they will have their maximum